At the heart of flipped learning course design is Understanding by Design, a model originated by Jay McTeague and Grant Wiggins during the 1990s. Understanding by Design, known as UBD, presents a holistic strategy for shaping curriculum, assessment, and instructional methods. This methodology revolves around two core principles: prioritizing teaching and assessment for genuine understanding and learning transfer, and structuring curriculum by first determining the intended outcomes. The UBD framework is anchored in 7 guiding principles. Thoughtful curricular planning enhances the learning journey, and UBD provides a flexible structure to facilitate this without imposing rigid guidelines. UBD guides curriculum and instructional strategies towards cultivating profound comprehension and the practical application of knowledge. Genuine understanding emerges when students independently employ and expand their learning through authentic performance. Effective curriculum design adopts a backwards path, commencing with long-term desired outcomes and progressing through 3 stages: desired results, evidence, and planning for learning. This guards against potential pitfalls like excessive reliance on textbooks or prioritization of activities over clear learning objectives. Educators assume the role of facilitators, favoring meaningful learning experiences over mere content delivery. Regular evaluations of curriculum units against design benchmarks enhance quality and encourage meaningful professional discourse. And finally, the UBD framework embodies a continuous enhancement approach wherein student achievements and teaching efficacy steer ongoing improvements in both curriculum and instruction. UBD is a widely recognized framework for underpinning flipped courses. Instructors employing UBD in course curriculum development proceed through 3 distinct stages. Stage 1, identify desired results, curriculum. Stage 2, determine acceptable evidence, assessment. And Stage 3, create the learning plans, instruction. The first phase of UBD focuses on defining desired outcomes, which involves a few key elements. This process includes setting clear objectives, creating enduring understandings, forming essential questions, and specifying what students should learn and achieve. Instructors should base explicit goals on university program standards, accreditation criteria, and course purpose. These goals then shape the creation of enduring understandings. An enduring understanding captures a fundamental concept with lasting relevance beyond immediate learning. It's a deep idea that holds essential principles within a subject. These understandings give students profound insights, promoting a thorough grasp of the subject beyond basic facts. Crafting a strong, enduring understanding begins with identifying a central concept and stating it clearly for students. For example, water cycles impact both Earth and society captures an enduring understanding in UBD. Furthermore, essential questions are a cornerstone of UBD, and understanding their essence is crucial. These questions should be open-ended, thought-provoking, and engaging, promoting higher-order thinking and transferable concepts. They require reasoning, evidence, and sometimes further exploration. Essential questions are important throughout the learning journey, crucial for design and teaching. For instance, how do water cycles affect ecosystems and natural processes? How do human activities influence water cycles? Essential questions come in 2 types: overarching, which apply to multiple topics, and topical, which focus on specific subject matter. Once the course aim, enduring understanding, and essential questions have been established, the next step is to create learning outcomes, what the students will know and be able to do by the course's end. To achieve this, Bloom's taxonomy is a helpful framework. This taxonomy categorises educational goals into different levels, with each level representing a higher cognitive function than the one before it. It's structured hierarchically, where each lower level builds the foundation for reaching the next higher one. The cognitive processes outlined in this framework describe how learners interact with and use knowledge. Imagine Bloom's taxonomy as a ladder of learning, guiding students through different levels of thinking. Picture this ladder as a journey of cognitive skills that students embark on as they engage with their education. At the top of this cognitive ladder is the create level. Here, students venture into the realm of creativity and innovation. They design, compose, and invent, crafting original ideas and solutions. It's as if they're artists of their own learning experience, using their imagination to produce new and unique work. Moving down a step, we find the evaluate level. Here, students become judges and analysts. They weigh the value of ideas, opinions, and information. Just like a critical thinker, they appraise, defend, and decide. This level empowers them to form well-justified stances and make thoughtful decisions. Continuing our journey, we arrive at the analyze level. At this point, students connect the dots between different pieces of knowledge. They dive into comparisons, contrasts, and explanations, uncovering the intricate relationships that shape our understanding of the world. Like detectives, they dissect information to reveal its underlying connections. Descending further, we encounter the apply level. Here, students bridge the gap between theory and practice. Armed with their acquired knowledge, they tackle new situations, solving problems and making use of what they've learnt in practical ways. This level empowers them to take their understanding beyond the classroom and into real-world scenarios. Stepping down again, we reach the understand level. At this stage, students become storytellers of knowledge. They explain ideas and concepts in their own words, demonstrating a true grasp of the subject matter. Just as interpreters, they translate complex concepts into comprehensible narratives. Finally, we land at the base of the ladder, the remember level. Here, students recall foundational facts and concepts, building a solid groundwork for their learning journey. Like archivists, they retrieve information from their mental libraries, laying the foundation for higher order thinking. Each rung of Bloom's taxonomy ladder offers a unique perspective on learning, guiding students towards different levels of cognitive engagement. Educators strategically choose which steps to emphasize, tailoring the journey to suit the learning objectives and needs of their students. Just as a journey requires a map, Bloom's taxonomy provides the roadmap for an enriching and comprehensive learning experience. To align with Bloom's taxonomy, an additional knowledge taxonomy can be implemented, encompassing the domains of factual, conceptual, procedural, and metacognitive knowledge. Factual knowledge, like knowing the vocabulary of a subject, sets the foundation. Conceptual knowledge goes deeper, connecting the dots between classifications, principles, and overarching theories. And what about procedural knowledge? That's about mastering skills, techniques, and methods unique to the subject. And lastly, metacognitive knowledge brings self-awareness to the table, helping students navigate cognitive tasks and understand the how and why of learning.